Hind everyone. Welcome to the lecture series of Mathematical Modeling of Manufacturing Processes with subject code KME 073. I am Dr. Suman Gotwal, working as an assistant professor in the Department of Mechanical Engineering at AKGEC Engineering College, Ghaziabad. So in today's lecture, we are going to discuss about the conventional machining. Okay. So if we talk about the machining process, we can define or we can classify it into two categories: conventional machining and the unconventional machining. So in today's lecture, we are focusing on the conventional machining only. So these will be the outline of today's lecture. First, we will discuss about the metal process. After that, we will discuss about the classification of the metal cutting processes. Then we will discuss about the general characteristics of metal cutting, disadvantages with the machining process, introduction to the machine tool, and then we are going to discuss about the single point cutting tool and the multi-point cutting tool. Then we will see how we can do the nomenclature of the single point cutting tool. So conventional machining process. So what is the conventional machining process? So basic difference if we see between the conventional and the unconventional machining process, that is, in the conventional machining process, basically the tool and the workpiece will always be in contact. Okay. But in case of the unconventional machining process, there will be a gap between the cutting tool and the workpiece, and a medium will pass through it, and we will remove the material from the workpiece. Now we will see how we can classify the metal cutting process. So by various types of processes, the metals are removed from the workpiece to obtain the required shape and size. So we can see here that we have classified the metal process into the cutting process and the non-cutting process. Okay, the conventional and the unconventional machining process. So here we are discussing about the conventional process only. So in the conventional also we can classify the cutting the metal process into the cutting process and the non-cutting process. So in case of the cutting process, we can see here the examples are the turning operation, boring operation, drilling, shaping and the milling. So what is the turning operation? Means in this we will remove the material from the workpiece, and here the workpiece and the axis of rotation. Okay, this is your workpiece, it is rotating, and this is your tool. The tool is, this workpiece is rotating and tool is moving in this direction, means the axis of rotation of the workpiece and the tool are parallel to each other. So by using the turning process, we will reduce the dia of the workpiece. Now what is boring operation? So in this we can enlarge the dia of the already drilled hole. In case of the drilling operation, we will drill a hole into the workpiece. It will be the new one. But in case of the boring, already drilled hole will be enlarged in the size. Then we can use the shaping operation, in which we are providing the particular shape to the workpiece. Then we can use the milling operation, in which milling cutter will be used to provide the shape and size to the workpiece. Then we come to the non-cutting operation, means we are providing the shape and size to a workpiece, but we are not removing any material from the workpiece. For example, the drawing operation. So in case of the drawing operation, basically the tensile forces are acting. So we will use the tensile forces and the workpiece will be stretched, and it will have the required shape and size, means it will become thinner, okay, in size. For example, if this is your die and the material is passing through it. This, we are using the tensile force here. Okay, so if the dia is like this, and after passing through the die, this opening, it will become thinner in thickness. Okay, then we can use the forging operation. So in case of the forging operation, basically the external force is applied on the workpiece to provide the shape. So we can have here the hot forging, cold forging, or the warm forging. Basically it will depend on the temperature at which we are processing the workpiece. So the external force can be applied with the help of the hammer, with the help of the presses, or some special purpose machines. Now we have the rolling operation, in which we use the number of rollers. We can use the single pair of roller, or we can have the a number of pair of rollers, and through it the material will pass. Okay, the material will pass. So it is basically used in the sheet metal operation. Okay, and here the compressive forces will act. Now we have the bending operation. So here the straight sheet is bended. Okay, for example, we can have the U or V shaped die. This one is your die, V shaped die. Okay, this is your straight sheet here, and we are using the punch. We are applying the force from here, so it will become it will bend in the V shape. So similarly we can have the U shape also. So we are providing, or we are bending our sheet with the help of the external forces. Then we have the extrusion process. So in this extrusion process also, the material is passed through a die, and then the force is applied and it will come out from a opening which is known as the orifice. Okay, and it will take the desired shape and size. So this is basically the classification of the metal process on the basis of the cutting and the non-cutting processes. Then we come to the metal cutting processes. Now we will discuss about the cutting processes only. So we can classify the cutting processes as the traditional processes like the machining, non-traditional processes, or the abrasive processes. Okay, in case of the traditional process, the material is removed by a sharp cutting tool, like we perform the machining operation, or when we perform the operation on the shaper machine, lathe machine, or the milling machine. So we are using a sharp tool to remove the work material from the workpiece. Okay, and the example are turning, facing, milling, drilling. Okay, then we come to the non-traditional processes. So in case of the non-traditional processes, various types of energies will be used. Okay, rather than the cutting tool, we will use the different form of energy to remove the material from the workpiece. For example, laser and electron beam machining. And here we will maintain a gap between the tool and the workpiece, and various medium of the medium will pass through this gap. Okay, so it comes in the unconventional machining processes, and this traditional is the conventional machining processes. Then we have the abrasive processes also. So here we will remove the material by the hard abrasive particles. These are very tiny particles, and we use the binding materials. We can use the binding materials and to give a particular shape to these abrasive particle, like we use the grinding wheel in the grinding operations. So we can use these loose abrasive particles also, for example in the lapping operation. So it will depend on the type of process or type of finishing we want to achieve. Now we come to the general characteristics of metal cutting. So before starting the cutting operation, we have to see what are the characteristics of the machining. So first we will understand this diagram. So in this diagram we can see this one is our workpiece. This one. Okay, this one is our workpiece, and this is the tool, this one. This wedge shape tool is a tool. So it started from here and we are seeing this when it reached here. So this one is basically the machined surface. Okay, this is the machined surface. Okay, and this portion, this line, this one is known as the rake face of the tool. Okay, and the angle between the angle, this one, this angle, the angle between the rake face of the tool and the perpendicular to the cutting speed or the cutting velocity or the direction of the tool movement is known as the rake angle. We have denoted it with the help of alpha. So this angle is the rake angle. It can be the positive or the negative one. Now as the tool is moving in this direction and it will remove some material from the workpiece. So this is the material, this one. This is basically the chip. Okay, so this TC is basically the chip thickness. Okay, this is the waste material, means this material is removed from the workpiece and this is the thickness of this chip. So this is TC is basically chip thickness. Now this angle phi, this angle phi is known as the shear angle and this is the shear plane, this one. This is shear plane. So the angle between the shear plane and the direction of movement of the tool is known as the shear angle. So shear plane is basically the plane along which the deformation will takes place. Okay. Now one angle is the clearance angle or relief angle. So clearance or relief angle is basically the angle between the machined surface and the flank surface of the tool. This one is the flank surface of the tool. So the angle between the machined surface and the flank surface of the tool is known as the relief or the clearance angle. Okay, and this is also known as the tool face. The cutting velocity is the basically the V. Okay, so here the material is deforming and this is the uncut chip thickness. Okay, TO is the uncut chip thickness. So we can see here the characteristics of metal cutting is thickness of uncut layer means TO, the thickness of the chips produced means TC, the inclination of the chip tool interface. Chip tool interface is this surface. Okay, this surface is chip tool interface with respect to the cutting velocity. Cutting velocity is this one. Okay, the relative velocity of the workpiece and the tool. There will be the relative velocity between the workpiece and the tool also. To make the cutting possible, a clearance angle between the job and the flank surface is also provided, because if the clearance angle is 0, it means the tool will touch this machined surface and the friction between these two surfaces will take place and our machined surface will get damaged. Now we come to the disadvantages of the machining process. Okay, so first one is the wasteful of material. Chips generated in machining are wasted material, at least in the unit production, because we cannot use the chips, so it is the waste. So here a lot of material is wasted during the machining process. It is a time consuming process. Okay, if we are providing a particular shape or size to a material, then we are using the sharp tool and the process will take time. So it is the time consuming process. So the machining operation generally takes more time to shape a given part than alternative shaping processes such as the casting, powder metallurgy or the forming operations. Okay. Now we come to the machine tool. So machine tool is basically a portable, power operated and reasonably valued device or the system of devices in which energy is expended to produce the jobs to desired shape, size and the surface finish. So, machine tool is basically the non-portable devices and a particular energy is required to provide the shape and size to a work material. Now, the tool, there is difference between the machine tool and the tool. Tool is basically the cutting tool, okay, single point cutting tool, multi-point cutting tool. So, these are the example of tool, but machine tool is like the lathe machine. Lathe machine is a machine tool, okay. By removing the excess material from the performed blank in the form of the chips with the help of cutting tools moved past work surfaces. Okay. Now, we will see these diagrams. So, as we have discussed in the previous slide also, that this is our workpiece, this is our tool, this is the rake face of the tool, this is the rake face of the tool, this one is the flank surface of the tool and this angle is known as the clearance angle, okay, and this perpendicular to the cutting velocity, the angle between these two is known as the rake angle, okay, and this surface is basically the chip tool interface, okay. This is the chip tool interface and this plane is basically the shear plane along which the deformation will take place. So, it is known as the shear zone, means in this particular area the plastic deformation will take place, and this one is the tool work interface, okay. Now, in terms of energy, because when we will cut or we will remove the work material, okay, when we will remove the material from the workpiece, then heat will generate because of the high temperature, the heat will generate. Now, we will see how this energy is distributed, okay, how the heat is transferred. Now, 18% of energy is converted to heat tool, okay. So, 18% of energy is transferred to tool, 2% of energy converted to heat, 2% of heat will be transferred to the workpiece and the 80% energy will go along the chip, okay, because if the more workpiece will get heated, means if more energy will transferred here and it will convert it to the heat, then our workpiece properties will change, okay. So, here we can see only 2% of energy is converted to heat in the workpiece, but here 18% of energy will be here and 18% of energy will be in the tool and 80% of energy will be in chip. Now, we come to the single point and multi-point cutting tool, okay. So, single point cutting tool is basically here only a single point will be in contact with the workpiece, okay. For example, we can see here facing on a vertical boring machine. So, here the facing operation is takes place and this is our tool, okay. This is our tool. So, it is the single point cutting tool. It is this tool is in contact with the workpiece with the help of a single point only, okay. Another example is like the cylindrical turning on a lathe machine. So, we have already, we must have seen it on the lathe machine, that how we will perform the turning and the facing operation. So, in case of the turning, we can see here this is our cylindrical workpiece and it is rotating and the tool is moving in this direction, and we can see here this it is in contact with the workpiece with the help of a single point and the material is removed to reduce its dia, okay. Now, we can see here internal boring on a horizontal boring machine. So, this is the already drilled hole and we can see here that the boring is taking place. Now, this is the production of a flat surface on a planer machine, okay, and this one is the production of the flat surface on a shaper machine. So, these are the example of a single point cutting tool or single point cutting operation. Now, where we use the multi-point cutting. So, in case of the multi-point cutting, like the example is the milling cutter or the drilling, where the tool is in contact with the workpiece with help of multi-points. Okay. So, we can see here that this is the tool and its shape. We can see here a number of teeth are here on its periphery, and all these teeth are in contact with the workpiece because this is rotating. So, it is the example of the multi-point cutting. Same, we are making a slot here, and this one is the blind or the through hole drilling operation. This is the broaching tool. So, in all the tools you can see multi-point cutting is multi-point cutting tool is used to provide the desired shape or size. The broaching on a vertical broaching machine. This is the reaming, which is a finishing operation. So, we can see here that a number of are provided here, and this is the forming tool to provide the shape. This is the dovetail. Okay. So, in all these operations we are using the multi-point cutting tool. Now, we come to the single point cutting tool nomenclature. Okay. So, there are different parts in a single point cutting tool. We can see here like the end cutting edge, face, flank, heel, nose, side cutting edge and the shank. So, first we come to the shank part. So, shank is basically the holding part, okay, and we can say this is the main body of the tool, and the shank is used to hold the tool hold. Now, we come to the flank. Flank is basically the surface or the surface below and adjacent to the cutting edge is known as the flank of the tool. So, this is the cutting edge, this is the cutting edge, this is the end cutting edge, this one, and this is the side cutting edge. Okay, there are two cutting edge, one is the end cutting edge and another one is the side cutting edge. The surface which is below or adjacent to the cutting edge is known as the flank. So, this surface is flank and this surface is flank. Okay. Now, we come to the face of the tool. So, the surface on which the chip slide is called the face of the tool. So, after the material is removed from the workpiece, it will slide over here. So, this is the basically the face of the tool. Okay. Now, we come to the heel. Heel is basically the intersection of the flank and the base of the tool. It is a curved portion at the bottom of the tool. So, we can see here the heel is basically this one, this surface. Okay, this is known as the heel. Okay. Now, the nose. Nose is basically the point where the side cutting edge and the end cutting edge will intersect. So, this is the nose, because here the side cutting edge and end cutting edge are intersecting. So, we can see here this one is the nose, this is the end cutting edge, this is the side cutting edge. So, here a small radius is provided which is known as the nose. Now, the nose radius, okay, that sharp point, that intersecting point is known as the nose, and a small radius which is provided at the nose is known as the nose radius. So, this is all about the classification of the metal process, which we classified in the cutting and non-cutting operations. Then we discussed about the disadvantages of the machining process. After that, we discussed about the single point cutting and the multi-point cutting, and last we discussed about the nomenclature of the single point cutting tool. So, that is all about this lecture. Thank you.